Hi, Assalamualaikum. We are from CEEC222-7C4A. My name is Alif AIMAN.
My name is ABDUL.
My name is AHMAD DHIHYAULQALBI.
And my name is Mohamad Farhan bin RIZAL.
So this video is for our group assignment, which we need to conduct 3 experiments. The first one is sand patch test, outflow meter test, and also the skid resistance test.
Before we conduct the test, we have to follow safety precautions, which should wear a reflective jacket and also safety boots.
Now we are going to conduct sand patch test. The objective of this test is to measure the macro texture depth of the road surface. Before we start, let me show you the apparatus used in this test. Firstly, fine aggregates are used. The sand must pass through 0.25 mm sieve and be retained on 0.18 mm sieve to ensure consistent particle size. Next, a metal funnel is used to reduce the sand spillage when transferring the sand into the measuring cylinder. A measuring cylinder is used to accurately measure 50 ml of sand for the test. Next, the spread disc is used to distribute the sand evenly, spreading it in a circular motion from the center to outward. A brush is used to clean the pavement surface to ensure it is free from loose materials, debris and moisture. And lastly, a ruler is used to measure the diameter of sand patch in at least 4 different directions to obtain the average value. To conduct the test, the first step is to select a suitable site location on the pavement surface. The pavement surface is cleaned using a brush to ensure it is free from loose materials, debris and any contamination. After that, approximately 50 mm of sand is measured using a measuring cylinder. A metal funnel is used during this process to prevent the sand spillage while transferring the sand into the measuring cylinder. The measured sand is then carefully poured onto the pavement surface to form a small pile. Next, a spreader disc is used to evenly spread the sand in a circular shape, starting from the center and moving outward until a uniform sand patch is formed. Once the sand is fully spread, the diameter of the sand patch is measured using a ruler in at least 4 different directions. These measurements are then averaged to obtain the mean diameter. Finally, the mean texture depth is calculated using the following formula in accordance with DKR specification, which is H equal to 4V over pi d squared, where H is the texture depth in millimeters, V is the volume of sand in cubic millimeters, and D is the average diameter of the sand patch in millimeters. Figure 2.2 illustrates the sand patch test result exceed the JKR minimum requirement of 0.5 millimeters. This indicates that the pavement surface at the Faculty of Civil Engineering parking lot has an open texture that allows effective surface water drainage. A higher macro texture depth improves the skid resistance, particularly for vehicles that travelling at high speed under wet conditions. It allows the water to be removed from the tire surface, hence maintaining adequate friction and improving road safety. In addition, mean texture depth is closely related to the outflow meter test, where pavement with higher mean texture depth values typically show shorter water outflow time due to more efficient drainage. Overall, the tested pavement surface is in good condition, suitable for Malaysia's climate and capable of reducing accident risk while enhancing long-term pavement performance.
Now I will conduct an outflow meter test. The objective is to determine the water drainage characteristic of a pavement surface. This is the apparatus used for this test. The apparatus used for this experiment, first is the outflow meter, which is contain a specific weight and a valve. Next is a tap water about 400 ml, and lastly the stopwatch to take a time to the water to flow. Close the valve to make sure the water is not flow, and then we take about 400 ml of tap water and put in the outflow meter until it reach 400 ml. Next,
First, ready the stopwatch, and then we will open the valve and we'll start the timer.
and after all the water is out, take a reading.
So repeat this procedure 3 times to get the average value.
This is a table of a result of outflow meter test. It shows the measurement of a different location from A, B and C. So from this test, we got a result of a time taken in second. And to get a discharge, we divided a volume with a time taken and we get a discharge. Show in the figure 1 is graph location versus time taken. From this graph, it show the time taken for location B is the highest and it's followed with the location C and A. This is the sand patch test result for the same location A, B and C. Show an average texture depth between 2.5 mm and 2.58 mm. This value is significantly higher than the JKR safety standard, which only require a minimum depth of 0.5 mm. Because the depth exceeds 2 mm, the road is classified as having an open texture. This means the surface is rough enough to effectively break up water films, providing an excellent grip and skid resistance for vehicle. To validate this finding, the outflow meter test is due, which record a rapid drainage time of just 6 to 8 seconds. This result confirm the texture data, the height surface roughness create large gap that allow water to flow away instantly. According to STM E23X0 standard, any drainage time under 10 seconds indicate a highly permeable surface, proving that the road is well equipped to prevent water build-up and ensure safety.
Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Alif AIMAN. In this presentation, I will explain the skid resistance test, including the test result, analysis, comparison with JKR standard, and the discussion of the findings. Next, we will conduct the skid resistance test using the procedure of ASTM E303-22. The objective of this test is to determine the skid resistance value of road pavement surfaces. So before we conduct this experiment, let's have a look of its apparatus. So here are the apparatus to conduct this test. The first one is the British pendulum skid tester that consists of a rubber slipper, 3 leveling screw, spirit level, pendulum arm, pointer, scale, and next we need a brush to clean the surface, and we have the pointer or the guideline for the rubber slipper. We need a ruler, water, and also a marker pen. So the first procedure is we will choose a suitable site location to conduct this experiment. And next, we will clean the surface of the pavement that to be tested from any debris or any small particles. After that, we will level this apparatus by adjusting these 3 leveling screw and make sure the bubble is at the center of the spirit level. After that, we will calibrate this apparatus by make sure this pointer is at 0. So we will make sure this pendulum arm is free fall or free swing. Let's calibrate this apparatus. So the pointer is at 0. So this apparatus is ready to be tested. Next, we will set up this pendulum up to make sure the rubber slip touch these 3 guideline point. So to make sure this rubber slipper touch the 3 guideline point, we will adjust the screw to make sure just touch the surface like this. Then for the second point, touch the surface, and then the last point, touch the surface. So this apparatus is ready to be used for the testing. Next, we will start conducting this experiment. First, we will test for the dry condition. Make sure this pointer is at the middle of the apparatus, and then we will release this pendulum arm by pressing this release button. And we will take the data. We will repeat this procedure for 3 times, and we will calculate the mean skid resistance value. Next, we will conduct for the wet condition. Make sure this pointer is at the middle of the apparatus, and we will release this pendulum arm by pressing this release button. Then we will measure the skid resistance value for the first trial. We will repeat this procedure for 3 times, and we will calculate the mean skid resistance value. This slide shows the results of the skid resistance test conducted on a rough pavement surface. Based on table 1, the average skid resistance value SRV under dry condition is 160, while under wet conditions, the average SRV is 95.67. The test was carried out at an average temperature of about 27 degrees Celsius for both dry and wet conditions. Next, table 2 shows the measured SRV value with the JKR standard. For road category C, which include campus roads, the minimum required SRV is 45. From the results, both the dry SRV and the wet SRV are significantly higher than the minimum requirements. This indicates that the pavement surface meets and exceeds the JKR skid resistance standard and is suitable for safe vehicle operations. The skid resistance test was conducted using the British pendulum skid tester, which is a commonly used device to measure surface friction at low speeds. The tester works by allowing a rubber slider to swing across the pavement surface. The loss of energy due to friction is then recorded as a skid resistance value, SRV. This method is particularly suitable for evaluating road surfaces such as campus roads and low-speed area. The objective of this test are to determine the skid resistance value under both dry and wet condition and to analyze the SRV results against the JKR standards. Skid resistance is mainly influenced by the micro texture of the pavement surface. As you can see the figure below, micro texture refers to the fine scale roughness of individual aggregate particles, which controls the direct contact between the tire rubber and the pavement. So, good micro texture increase friction and improve braking performance, especially at low speeds and during wet conditions. When we compare the results, we can see a clear difference of SRV between dry and wet conditions. The SRV in dry condition is 116, while SRV in wet condition is 95.67. The pavement shows better skid resistance in dry conditions, mainly because the tire is able to make full contact with the aggregate surface, which increases the friction. However, Under wet condition, the situation changed. Water creates a thin layer on the pavement surface, and this layer acts as a barrier between the tyre and the road. As a result, the friction is reduced, and this explains why the skid resistance value is lower in wet conditions, even though the surface condition remain the same. The skid resistance results were compared with the Transport and Road Research Laboratory (TRRL) 1969 requirements, which are adopted by JKR in the absence of locally established SRV standards. Since the study area is a campus road, it is classified under Category C, which represents all other sites. As you can see from the figure below, the minimum requirement skid resistance value is 45. Based on the results obtained, both the dry SRV and wet SRV values are significantly higher than this minimum requirement. This clearly indicates that the pavement surface exceeds the skid resistance standard and provide adequate friction and good braking performance. Therefore, the road surface is considered safe and suitable for low-speed campus road conditions, especially during wet conditions. Although the results show a good resistant performance, there are several limitations that need to be considered. Firstly, the measured skid resistance values can vary depending on external surface conditions such as temperature, surface cleanliness, and the presence of the moisture. For example, dust or debris on the surface can reduce tire and road contact during testing. Secondly, it is important to note that the British Pendulum Skid Tester simulates skid resistance at low speeds only. Because of this, the results are more representative of campus roads and low-speed environment rather than high-speed highway. Therefore, while the results are suitable for evaluating low-speed road safety, additional testing methods would be required to assess skid resistance performance at higher vehicle speed. As a conclusion, the tested performance shows a high skid resistance under both dry and wet condition, which is exceeding the JKR requirements. This indicates that the pavement surface is safe and suitable for low-speed campus road applications.